So this is another PowerPoint working with partial pressure and specifically working with PV equals nRT, otherwise known as PIVNERT. So number one, during an experiment, 17.5 milliliters of oxygen gas were collected over water at room temperature, which is 25 degrees Celsius, and 100.2 kilopascals of atmospheric pressure. The vapor pressure of water at this temperature is 2.6 kilopascals. A. What is the pressure of the dry oxygen gas? Well, using Dalton's law, which is the pressure of the total gas equals the pressure of gas A plus the pressure of gas B, and so on, you can which for this particular problem would be P of the total equals P of oxygen gas plus the P of the water vapor in the oxygen gas. So in order to find the pressure of the dry oxygen gas, you subtract the pressure of the water vapor from the pressure of the total. Using a table of water vapor pressure correlating to temperature in the other slideshow of partial pressure, you can see that 2.6 kilopascals corresponds to 25 degrees Celsius. So you can subtract 2.6 from 100.2 and you get 97.6 kilopascals, which is the pressure of the dry oxygen gas. How many moles of oxygen gas were produced? The volume, since there are 1,000 milliliters in 1 liter, the volume is 0.0175 liters. R is a constant at 8.31, and the temperature is 25 degrees Celsius plus 273 to get you 298 Kelvin. So then you can just plug in what you calculated or what you were given to get 97.6 times 0.0175, which equals n times 8.31 times 298. And then you just rearrange the equation to solve for n, and you get 6.9 times 10 to the negative fourth moles. C. What is the molar volume of the oxygen gas at the conditions in the lab? You can solve for the molar volume equals using RT over P, which is a rearranged version of PIVNERT. R is still 8.31. T is 25 degrees Celsius plus 273, which is 298 Kelvin. So then you could just plug in your values using the answer from A for the pressure. So it's 8.31 times 298 over 97.6, which is 25.4 liters. Number 2. Zinc metal reacted with hydrochloric acid and 448.5 milliliters of hydrogen gas were collected over water at 35 degrees Celsius and 95 kilopascals of pressure according to the balanced equation. Zinc plus 2 hydrochloric acid goes to H2 plus zinc Cl2. How many moles of hydrochloric acid were used up in the reaction? You can use the equation PIVNERT in order to find the number of moles of H2 created from the reaction. The volume is 0.0485 liters since there are 1,000 milliliters in a liter. R is still constant at 8.31, and T is 308 K because you only need to add 273 to 35 degrees Celsius. So you can rearrange PIVNERT to get PV over RT equals N of H2. And then just plug in the values. So 95 times 0.048 over 8.31 times 308 equals 0.018 moles of hydrogen. Then you can use the balance reaction to find the number of moles of HCl that were consumed in the reaction. Since 2 moles of HCl were consumed for every 1 mole of hydrogen produced, you can multiply the number of moles of H2 created in the reaction by 2, which is the value that you just calculated. So 0.0018 moles of hydrogen times 2 moles of hydrochloric acid equals 0.0036 moles of hydrochloric acid consumed. Number 3. A gas was collected in a 2-liter container over water at 40 degrees Celsius and the pressure in the container was 105 kilopascals. What would be the volume of gas at STP? STP stands for standard temperature and pressure. So at STP, temperature is 273 Kelvin and pressure is 100.0 kilopascals. First, you have to find the number of moles of gas in the container using PIVNERT. Using Dalton's law, you know that the pressure total equals the pressure of gas A plus the pressure of gas B. So you know that the pressure of the total for this problem is the pressure of the gas plus the pressure of the water vapor. So the pressure of the gas equals the pressure of the total minus the pressure of the water vapor. And the pressure of water vapor at 40 degrees Celsius is 7.4 kilopascals. So 105 kilopascals minus 7.4 kilopascals equals 97.6 kilopascals, which is the pressure of the dry gas. R is still 8.31, and the temperature is just 40 degrees Celsius plus 273 Kelvin, which is 313 Kelvin. Then you can rearrange PIVNERT in order to solve for N, which is PV over RT equals N, and then plug in the values, and you get 0.075 moles of gas. So then plug in the STP values, and you get